We use many gadgets in our day-to-day lives which uses digital means to operate, such as cell phones, computers, consumer electronics like microwave oven, washing machine, etc. But the parameters that are used for operating these gadgets or devices are physical quantities like current, voltage, light, etc., which are analog in nature. But instead of using these analog parameters directly, we convert them into digital and then we use them in our devices. So why do we do so? That is because there are many factors regarding data security, quality of data at long distance over transmission, and most importantly, immunity of data or immunity of signal over noise, for which digital signal processing is highly preferred over analog signal processing. Hence, for converting the data from analog to digital, we use a device in every circuit, which is known as analog to digital converter, also known as ADC. So, in order to perform digital signal processing on the natural signals, which are analog in nature, they must be first sampled and quantized into digital form. Now, what is sampling and quantization? So, sampling is a process in which we convert a continuous time signal, that is our analog signal, into a discrete time signal. And quantization is a process in which we provide finite values to each sample that is generated by sampling. So on your screen, there is a basic block diagram of ADC, which shows that the analog signal is provided as input, which is first sampled, producing a discrete time signal as the output. And then this discrete time signal is given as input to the quantizer, and that signal is quantized, giving each sample a value, and hence digital signal is obtained in the output. The sampling operation is usually performed by sample and hold circuit, while quantization is performed by a quantizer. So let us see what a generic sample and hold circuit looks like. So on your screen you can see the sample and hold circuit. So the working of sample and hold circuit can be easily understood with the help of working of its components. The main components which a sample and hold circuit involves is a N-channel E-MOSFET, a holding capacitor to store the charge, and a high precision operational amplifier. The N-channel MOSFET will be used as a switching element. The input voltage, that is uh, the analog voltage, it is provided through the drain terminal of the E-MOSFET, and the control voltage will be applied through the gate terminal. So when the positive pulse of the control voltage is applied, that is when the positive voltage is applied, then the switch acts as a closed switch, and when negative voltage is applied, the switch acts as open switch. So let us understand the working of this sample and hold circuit using the waveforms. So consider that this is your analog input signal, that is Vin. This is your control signal, that is Vs or Vg, and this is your output signal, that is Vout, that you obtain at the output. So what will happen here is when the MOSFET acts as a closed switch, the analog signal applied through it through the drain terminal will be fed to the capacitor over here, and the capacitor will be then charged to its peak value. And when the MOSFET switch is opened, that is when the gate or control voltage is low, then the capacitor stops charging, and then the capacitor is discharged. But as you can see in the circuit, that there is a very high impedance provided to in the input of the operational amplifier, that is this 10 kilo ohms. So due to this, the capacitor cannot get discharged, and the capacitor experiences a high impedance. So this leads to the holding of charge by the capacitor for a definite amount of time. Okay, so in the let us understand this using the waveforms. So this is your analog signal and this is your control signal. So how will you obtain the output? So during the time period for which, so for this much time period the gate voltage is provided, and for this much time period only the MOSFET acts as a closed switch. That means whenever the MOSFET acts as a closed switch, it allows this analog voltage to pass through it. That is, it will allow the analog voltage to pass through only for the time while it is closed. And when the and during that time this capacitor, this holding capacitor, it gets charged. And when the switch is closed, then the MOSFET will act as a closed switch, open switch, sorry. And while the MOSFET acts as an open switch, uh, the capacitor will try to discharge itself, but it could not, because there is a very high impedance in the input side of the operational amplifier. As you can see in the picture, there is a 10 kilo ohm resistance provided at the input of the operational amplifier. So what will happen is the capacitor will hold the charge for a definite amount of time, right? So the capacitor will hold the charge for the definite amount of time, and then again when the pulse is high, again this switch will act as a closed switch, and the voltage will be allowed to pass through it, right? So in this way this procedure will go on and on. So here the holding, so the time for which the capacitor holds the charge, it is known as a holding period, and the time in which the samples of the input voltage is generated, it is known as sampling period. So in this way the samples are generated using the analog input value. Now as for the quantizers, there are the quantizers depend on different types of ADC architectures. Now there are several different types of ADCs that are being used in the circuits. So we will see the types of ADC and their architectures in the upcoming videos.